So we started to build up our plot. Things are getting very exciting. We're starting to see relationships between our characters. We're starting to see things that happen that we were expecting, and we're also starting to see things that were happening that we were not expecting. Some weird data points, some interesting data points. The plot thickening is very exciting. So one of the things we're going to have to come to terms with is which of these trends and exciting points are meaningful and the most meaningful. And one of the topics that we have to think about here is p-values. Now, p-values are probably one of the most misused statistics in human history. And you can see here that there are many scientists and data scientists, statisticians that are not comfortable with what exactly a p-value is. However, for the purposes of this course, we're going to think of a p-value as a pretty good estimation of whether or not the trends and results that you're seeing are happening in the real world or whether they're caused by chance. This is a very, very simple, incomplete version of what a p-value means. And you could spend several years studying p-values and then debating them online. But for this course, we're going to just use them as this. A p-value can measure whether an observed result is happening by chance. A p-value cannot measure how meaningful your result is. A p-value cannot measure how biased your data is. A p-value cannot measure how good your question is. All those things are based on things well outside what a p-value can measure. Regina Nuzzo has one of the best articles of all times on p-values and how to think about p-values and what they mean. Her article's in our resources. I highly recommend you take a look. But you'll notice that in the Tableau trend lines that we're looking at, each one comes with a p-value. And in the world of science, a small p-value is considered usually to be a better p-value. The smaller the p-value is, the more likely it is that the results you're seeing are actually happening in the real world rather than just being caused by the chance that's present in your data. And a result is said to be statistically significant in most cases if the p-value is lower than 0.05 or 5%. Now, this is an arbitrary number that's simply socially agreed on by the scientific community. Some people prefer to use 0.01. That's a stricter threshold for statistical significance. A typical piece of research would use 0.05. However, what is typical and researchers' relationship to p-value is changing quite a lot. For the purposes of this course, we'll count 0.05 and lower as a significant p-value. But a conclusion that is something is statistically significant does not mean that it's practically significant. It does not mean that it has meaning to your readers. Basically, in this course, we'll take a p-value to mean this event is probably happening in real life and we should pursue it further. In addition to looking at the p-value, the statistical significance, you'll want to think about the practical significance. Statistical significance is about the likelihood that the effect is there, not by chance. Practical significance means that the effect is somehow meaningful in the world, meaningful to your readers, worthy of your time and attention. For example, if you have a really large data set, you can get a very small p-value for a really small difference. You see this a lot in public polling. If there's a public poll that involves 10,000 people and they're asking whether there should be a new bridge built in your community, and they want to look if there's a difference between men and women, they can analyze that data and say, yes, there is a statistically significant difference between the percentage of men that want this bridge built versus the percentage of women that want this bridge built. The p-value is very, very low, 0.00015, because they have a huge sample. However, if you look what the numbers actually say, it could be that 51% of men want the bridge built and 52% of women want the bridge built. So that is probably not a practically significant difference, even though with a big enough sample size, it could be a statistically significant difference. So it's important to think about both practical significance and statistical significance. And finally, when you're writing up your story, probably avoid using the word significant unless you are working directly with a statistician. There's a lot of other words that can convey more accurate meaning. Whether a difference is substantial, whether a difference is meaningful, whether a difference is consequential may be more important than when a difference is significant.